Hello guys, so I'm about to solve a question. I put the question on the screen so that you can see. It's a calculus question. Actually, it's a differential calculus question. So the question simply states that we should show that if y is equal to x root of 4x plus 1, that's a we should show that dy dx is equal to 6x plus 1 all over the square root of 4x plus 1. Then b, we should solve dy dx minus 5y is equal to 0. So the first part I want to, okay, let me just write the question out. It said given y is equal to x times the square root of 4x plus 1, we should show that, let me write it, to show that, okay, since the question is on the screen, I will not bother to write that part again. We show that dy dx is equal to 6x plus 1 all over 4x plus 1. So it simply means, when they say dy dx, simply means we should find the derivative. The question can come in different ways. The question can say we should find f prime of x. Questions can just simply say we should differentiate. So to differentiate this, as you can see, it's a product rule question. We can say let x represent u and let v represent the root of 4x plus 1. So, but one thing we should know is we are looking for two things, du dx and dv dx. Our product rule has a formula, and that formula is that, let me just write it out, dy dx is a formula everybody should know by heart, is equal to u dv dx plus v du dx. So you can see u and v, we have used them to represent x and the other value there. So what we are looking for is our dv dx and our du dx, which means the derivative of those individual functions. So, and we are working with our general differentiation rule, which said that given any polynomial is just a function that is carrying a power which can be positive or negative. Given any polynomial in the form of x raised to the power of n or ax raised to the power of n, the derivative is going to be n ax or anx raised to the power of n minus 1. So that's what we are going to be using. So as I'm doing it, I'll try to be explaining. So u is x and our dv dx is, now this is very crucial because our v here is actually a function of a function. I can also write this my v, I can write this as 4x plus 1 all raised to the power of 1 over 2. For those of us that understand indices very well, we'll get why I put this as 1 over 2. So it's actually a fractional power law. That is why the 2 and on the denominator here is indicating the square root here. If it was a cube root here, this would be 3. I don't want to go into to digress into indices, so let me just continue. So this is a function of a function, and I work with chain rule. I'll create a video on explaining chain rule in depth for those of us that don't understand. But what we are going to have for our dv dx will be something that looks like this: 1 over 2 into 4x plus 1 all raised to the power of minus 1 over 2 multiplied by 4. Okay, I think that's bold enough. Plus, move to the second part. Our v is this, it's root 4x plus 1, as we can see, but I'm going to write it as 4x plus 1 raised to the power of 1 over 2, just so that it will look something like this one here, because eventually we are going to look for a common factor to simplify further. So our du dx is actually just 1. Why is it 1? Okay, let me just explain that briefly. Remember, x is a polynomial that is carrying a power of 1. So, and I said we are using the formula given x raised to the power of n, which in this case is actually x raised to the power of 1. X raised to the power of 1. No, I'm trying to put power of 1 there. I hope we can see it. X raised to the power of 1. The derivative will be nx raised to the power of n minus 1. So our n, which is 1, comes to the back, multiply the x, then we'll subtract 1 from the power, which is 1. 1 minus 1 is 0. Anything raised to the power of 0 is 1. So x raised to the power of 0 gives us the 1 back. So like I said, if you have any questions or you're battling with general differentiation rules, proving how did you actually come about this rule, they all have their proof. So I can explain that in depth. You can put it in the comment box and I will try to explain that in depth. So simplifying this now, we can see that something is common between these two. I'm going to bring out 4x plus 1 all raised to the power of minus 1 over 2 as a common factor, and I'll use that to simplify. Of course, 2 divides 4 here to give us 2, and 2 multiplies by x will give us 2x. So I think we are clear with that part. Plus, on this side, 4x, since this I'm trying to use in this idea, since these are same base, and if you are multiplying this by something here, it's addition law of power, since it's multiplication gives addition in indices. So I'm going to be having 4x, let me put it in bracket, 4x plus 1 all raised to the power of 1, because minus half, just put it there just for formality so that you can see clearly that minus half plus 1 will give us positive half here. Good. So I can put this one here, but it will not make any difference. So I'll close my bracket, and I will simplify what is inside. 4x plus 1 over minus 1 over 2. I shouldn't have even written this again. 2x plus 4x give me 6x plus 1. Sorry about that. So everything we have here is just, I can still rewrite it as 6x plus 1 all over the square root of 4x plus 1. Remember negative power law here and fractional power law. So it will come down, and because of the negative sign, to come down, then because of the fractional power, I'm having my square root. Remember what happened in the beginning. So this is the A part of the question. We are correct here. Then the B part of the question says we should solve dy dx minus 5y is equal to 0. Now what that simply means is this is already our dy dx. We've gotten it. Now what is 5y? Since our y was given in the question initially, it means I will just write my dy dx plus 1 over 4x plus 1 minus 5y. My 5y now is going to be 5x, the square root of 4x minus 1. If I simplify this, what am I going to have? The LCM is 4x plus 1. When I simplify, I'm going to have, this goes here 1, that's 6x plus 1 minus this goes here 4x. So this goes here 4x plus 1, 4x plus 1, sorry about that, this is plus 1, 4x plus 1, I was rushing too much. The LCM is actually square root of 4x plus 1, sorry about that. So 4x plus the square root of 4x plus 1 times the square root of 4x plus 1 will give us square root of 4x plus 1 square. Square cancels square root, and we are left with 5x, I put it in bracket because of the negative sign, 5x into 4x plus 1, something like this. And once I simplify this, what do we have? We have 6x plus 1 minus this is 20x squared minus 5x, everything all over 4x, the square root of 4x plus 1, and this is equal to 0. Well, coming back to that, if we simplify this, I'm going to have 6x minus 5x will give me just x plus 1 minus 20x squared over square root of 4x plus 1 is equal to 0. If I multiply both sides by this to eliminate this denominator, I'm going to be having 20x squared minus 1 minus x is equal to 0. So what I simply did is I multiplied through by negative sign here, so that I will not be having minus 20x squared, I'll be having 20x squared. So once I factorize this, I'm going to get two values of x. You can see that it's a quadratic function. I've got two values of x, and I will now use those two values of x to also substitute in the initial function so that I'll get two values of y. So the question is really getting too long. I'm going to stop here, but we can use either complete square method or mighty formula, or just use our general method. Thank you for watching.